Okay, so thank you everybody. My name is Bibraj Haldar, founder and CEO of Safe AI. Really great opportunity to actually I learned a lot from the last two presentations. So it's actually really great. I'll build it on top of it. And today I'll kind of focus on what I call the path to open and interoperable ecosystem in mining. I'll not use too much time in this slide. I think the past speaker spoke at length, and I actually learned a lot from them. But the summary of that is that autonomy in mining is not new. It is very mature. There is over 800 of them are currently running in various mine. So there is a lot of data being generated and gathered over last 5-6 years, and I think last speaker really highlighted a lot of very valid point. Where we come from, take a look at it, is that we all understand the ROI. Yes, it is not all realized, but the safety condition improvement, the overall operational improvement, the reliability you get in the operation, all that has been very clear for about last 15 years, if not more. And actually autonomous mine goes all the way back to 90s, but it's been very actively going on for the last 15 years. But still, when you see 800 of them in production, that is less than 3% in the overall asset that could be autonomous. So the question we ask, why is that? And more than the why, I think I had a talk a couple of months ago where we discussed that in detail. But today I'll kind of focus on how can we kind of accelerate or solve that problem. And there are a lot of vertical, if you will, to look at what can be we all do. And I think GMG is a good example, right? The reason we are coming together is to solve that problem and help kind of the whole community. But today I'll kind of focus on a very narrow technical area, where is that open and interoperable architecture. So what do we mean by open and interoperable architecture? And I think everybody's kind of have a very high level idea, and obviously there's a lot of workshop going on around that, but really it means that you want to detach the equipment from the autonomy. So if you are using the onboard autonomous solution, you should be able to put it on any equipment and kind of transferable to any places. Think about this way, that if you're buying a computer, you're not married to the operating system. You can flash out your Windows operating system, put a Linux operating system tomorrow. So it's not really tied to your computer. Same way, a autonomy software has nothing inherent to be tied to any equipment. Same with that hardware. So if you think about, there is a set of hardware you're going to attach to a machine, it got nothing inherent that it has to be exactly for that same machine. This hardware should be very interoperable into one hardware to another hardware. Then going back to the third piece, if you will, the management system. This is where the FMS system lies. This is where orchestrating everything is happening. Again, the same idea. If you're using a software, you are not tied to a particular cloud operating system. If you think about in the consumer market, you can use the Google Cloud, you can use the Apple and Amazon AWS. So there should not be a very tied down, and this should be very much open, and you should be able to pick any equipment, any autonomy, any management system, mix and match that is best for you, and almost have your pick based on your use case. And I think that's the open and interoperable future we are going for. A little bit of deep look at the same kind of look at it. And if you want to zoom it out a little bit, there will be a V2V component. This is what we kind of zoomed out into one equipment, but there is also a communication that goes from the manned, because there will be a manned and autonomous working together. There will be a communication between those two. So these are all working in a very modular way. So you can put any autonomy that will talk to any manned equipment. You can put any autonomy algorithm that will talk to any management system, and that's the future we are envisioning. And I'll kind of take a like kind of say what really motivating it. Yes, it's a good idea, but why we didn't do it, or mining industry didn't do it last time around, if it is such a good idea. And I'll tell you why is it a good idea. Is really not that we didn't know 10 years ago or 15 years ago. We knew that modular architecture is better, But the reason last time around it happened that way, but now is the right time, is because really the technology. What happened, autonomy, think about autonomy before 2014. This is where the traditional autonomy is running. This is where well tested 800 of them was running in the operation, but they were before 2014. Why it is important? Really, 2014, where is the AI part, if you look at this one, fundamentally shifted the whole algorithm underneath. So before 2014, this whole DNN was getting developed, if you will. By the time we come here, this is where we realize if you want to do autonomy, AI is going to play a big role into it, which was not the case quite a before that. And this is a, think about a tectonic shift in autonomous algorithm, if you will, that really pushing everybody towards the what we call a, we dubbed as a autonomy 2.0. And because of this technology push, why this interoperability is going to be a lot more very available today. So this is really the one of the core reason behind this. And before we kind of get to that how to do it, and I will get down to a little bit of detail, technical detail, because I thought last two speaker have really set the very nicely high level motivation and what the stage is. So I'll actually dive into detail in the technical side, how do we get there. But think about, why do you want to do that? Why do you want to do interoperability? One thing is the share the lesson learned. So basically there are a lot of pieces of the puzzle, and I think the last speaker pointed out is that there is not enough experts either way, whether to develop the autonomy or how to deploy it in the site or overall system. There is not enough people to go around for accelerating this. So you want to be able to share the lesson learned. You want to be able to pick and choose the pieces that other people already spend the time, developed it well. You don't want to develop it in your house, again doing the reinventing the wheel. Second thing is that, if you think about the whole ecosystem from the vehicle to the cloud, you got this vehicle system, then you got an autonomy system, then you have the communication piece, then you have the cloud piece, FMS and orchestration system. It's just too complex. You literally have no entity in the world beside probably Apple and Google in the world that has all the expertise in one under one roof. It's just not possible. Again, Apple and Google are probably only exception in the world on that. Literally, it's too complex for any one entity to do. So you almost have to get the best of the expert in the room, let them do their part, and then mix and match and execute for your use cases. And the third piece also very important, right? You want to distribute the risk and the financial responsibility, because this is still, there are, as we are pushing it further, the environment, it is going to be, there are a lot of unknowns going on. It is not that we know everything. Yes, there is a traditional last 10 years has been going on, but you're trying to push it to, let's say, what I think 2000 of these, there's a lot of unknowns in front of us. You don't want to be taking all the risk under one roof. You want to be able to distribute the risk, both the risk to try out different ideas, also the financial responsibility. I think these are the three key reasons, and that will help you kind of accelerate the progress. With that, maybe I'll kind of dive into a little bit of detail when you talk about interoperable, and I'll get a little more technical. I think this audience is fairly expert audience, so I'll get into a little bit more technical than the I think what I did last time around. So when you look around, you're really looking at very distinct pieces, and I zoomed into one equipment, and you're looking at the vehicle. So there is a vehicle level experts are there. Then you are looking at putting the hardware and making the vehicle ready for autonomous. So that's the second kind of experts, if you will. And there is an interoperability come here. What I mean by that, you should be able to design in a way that these pieces can be go from one vehicle to another vehicle to another vehicle very seamlessly. Then you're looking at the algorithm that goes on the vehicle that makes the vehicle autonomous. It doesn't have to be fully autonomous. It can be, driver assist, but all the way to fully autonomous. Again, in that box, there are a lot of pieces in the puzzle that can be broken down and maybe focused on different way. And I'll talk about that. So there is a little bit of interoperability and modularity here. Then when you leave this vehicle and talk to the other vehicle, other manned equipment, if you will, it could be a loader, a dozer, a light vehicle, maybe another autonomous truck running somebody else's autonomy, you need to be able to seamlessly communicate. And it shouldn't be matter what autonomy you're using or what mobile equipment you're using. They should be talking openly, and there should be a standard on right here. The last piece is the puzzle is right here. Again, this allows you to be able to talk, have your equipment talk to any management system, and you can call it a fleet management and overall management system. That API should be also seamless and open. Two reasons. One is that you can plug and play whatever component you want here. It could be from one vendor, it could be from multiple vendor compiled, it could be a combination of part was developed by one vendor, but they keep you an API and a platform. You are developing your application on top, but this API holds true so that everybody can develop on top of it. I know there are some standards going on, but these are the kind of way to break this component out. And the last piece, I think this one where you how you're designing the how to do mining kind of get into the in your cloud solution as well. And I'll touch upon this connection, connecting tissues, if you will. So let's talk about the hardware first, right? One thing you want to look at, obviously there is a LiDAR, radar, camera, GPU, GNSS, all kinds of equipment. At this stage, you don't want to get married to that. So you want to be in a position, you develop your algorithm in a way that you would be able to switch out your LiDAR from one LiDAR to another LiDAR. Today it is this LiDAR, tomorrow somebody else is giving you a better solution, you should be able to switch it out. Same with radar, camera, even your compute platform, any of those components, you want to be able to be interoperable. You want to be able to switch it quickly, get the best of the breed that is available today. Because one of the things happening in the world right now, these sensors are accelerating at a pace that never seen before because of the amount of investment and the people interest. There are probably tens of companies who are developing LiDAR, and it will only get better and better every year we move across the time. Same for all the equipment. So that's the one side of the interoperability. Another side of the interoperability is that you want to be designing the location where you are inputting this hardware in a more modular way. What I mean by that, let's say I developed one for Cat 793. You should be literally able to take this same sensor, put it back into a truck which is much smaller form factor. Let's say Cat 725. This is a different world, right? This is a 25-ton truck, extremely small compared to a 793. You should be able to design this module in a way they come almost in a packet. Maybe you're putting more camera here, but let's say think about you're putting LiDAR, radar, camera combination right in front. You should be able to just take it out, bring it here, put it right in front of it. They should be very modular. That way you are actually utilizing your hardware much, you're not redesigning for every vehicle every time. Otherwise it will be hard for you to scale up. That's why you, again, going back to the why 800 in 5 years, we could have done it 10,000 of this equipment. So some of them prohibited you. So if you nailed out the design that, okay, this is how it's going to be, you make the design in a way that even if you are saying it's a LiDAR radar combination, you should be able to switch those LiDAR radar from inside, but this block remain same, if you will. So that's from the hardware interoperability point of view. Because another part of is sometimes not all of this truck everybody use for years and years. They might want to take it up from the one truck and put it into another truck because they are different type of miner. They might not be those, the miner who does 10 years, same thing. They might do a project for 1 year, 2 year, and they want to take this stuff from one truck to another truck. Second thing is the drive-by-wire interoperability. What is the vision here is that you have two type of truck. You are able to put a hardware into this both. They can talk to both of these vehicle, and then on top of that there's a set of features this box is performing. We call it a equipment interface module, but this is really drive-by-wire box. So what is doing is one side of this is communicating with the truck, another side is communicating with Autonomy Software, through this API. Again, this API become the central piece where this API holds. Now you can take buy this box. This box, you know exactly what feature is going to perform. It has been tested for safety. It has been tested for validated for everything. It has it can control equally whether it is a 220-ton truck or whether it is a 40-ton truck. It will control same way, and you hold that API. So now any autonomy can kind of come on top of it, and they know exactly that now that they know what this is going to talk, they can develop their algorithm on top because they have this API fixed. And this box also gives you a guarantee that what is this box is going to perform. So in your way you can design it better. And if you are a if you are the mining company or you are the developing the algorithm, you can always buy this off the shelf, saying that I am not the one who are experts on this. Let somebody figure it out, let somebody do the safety cases for it. But when I get this thing, I know the API I can develop on top. So that gives you this drive-by-wire level interoperability. I think this is obviously very important from porting autonomy from one vehicle to another vehicle. A little bit on the software side, going inside in the software. So when you look at the autonomy software, so what you're looking at, just to kind of go back, you're looking at these blue pieces, right? That is the software that makes the vehicle autonomous, that sits on your vehicle. So literally think about, there is a box where it has a heavy CPU GPU MCU combination. This box goes inside your vehicle, and actually this is what replaced the operator. So all the logic is in that box. But even in that box, it is not a black box. It was black box last time around, but it is not a black box really. There is a very nice logical separation even inside the box. One separation is that you want to be able to develop the software. Think about this software is an application. This is your autonomy application. You want to be able to develop your autonomy application on top of a trusted framework. So the way you want to think about this one is that this is your iOS or Android. Any app can develop on top, but iOS and Android is kind of fixed, and you are not worried about low level detail. You're just developing your algorithm and application on top. So this part is very modular. So literally, and everybody developing this part, certifying this for safety, testing it out, making sure it is compatible to all kinds of hardware underneath, all kind of operating system underneath. It just, it's a waste of time, and not barely enough people in the world has the expertise who can consider on that. And more importantly, this is not your value differentiator. This never, like, you don't buy an app on an iOS because it is on iOS. You don't really care. You are looking at the app. Then you are obviously, this is the autonomy algorithm. I'll kind of slice that down as well. Then there is a safety layer. I put the safety layer on top, and I'll have a little bit of comments on that. But really, it's not on top. Safety layer kind of goes across the whole value chain. Again, there is a lot to be learned and shared across the whole community. This safety layer also is not something that is value differentiator. This is, everybody has to do this. It is everybody's interest. We do it right, we deploy it right. And if somebody figured out in some pieces of the puzzle how to do it right, it's better to share across the whole community. So when you're looking at, if I kind of double click on this software part, I think when I was thinking how to present it, and this is kind of came to my kind of visualization of that, you really want to think about this software is almost like a pieces of the puzzle, right? And these pieces of the puzzle, if you're not a software person, you want to think about in a sense of features. So they come together, and let's say if you take 5 pieces of this puzzle, maybe that will give you a driver assist feature. Maybe if you take 10 pieces of the puzzle, that will give you all the way up to fully autonomous. Maybe you need a 20 piece of the puzzle to really deploy in a very complex scenarios that maybe in a simple scenario wasn't working. So, but this is very modular. You could take these pieces out. Either you can think of it as a piece of algorithm, or you can think of it as a piece of features, and it nicely tied together, and you adding more and more to creating the full autonomy. So, and that is how the next level, next generation autonomy 2.0 algorithm is written, and develop. And this was one of the difference between 10 years ago versus now. 10 years ago we didn't know enough. 10 years ago autonomy was just getting 10 or 15, however you want to go back. We were developing everything from scratch. But today the world has changed. A lot of the thing has been standardized. A lot of the thing has been flushed out. These Googles and Apple been working on it for 5-10 years. A lot of thing has been flushed out. There is no reason to recreate and not and figure all those things out in 2020. So this is, it's a very modular architecture by nature. If I want to go a little bit more inside what I mean by modular, really this is now going into the next look into that, right? Not want to go into the detail, but what I'm getting at is that even in this, each of those block, if you want, you can double click on that and you see something like that. Even in that each feature, there is a 10 or 15 of box which individually put together in algorithm fashion, and they are very nicely connected in an API. So all those boxes nicely connected in an API, and you hold that API down. Let's say you want to have a object detection in a fusion from somebody else. You can do that because if you hold on to that API. Again, the advantage is that if you are developing your own and you figure out somebody has some box which is better and this is well tested, it is working well, every industry is using it, let's use that box instead of reinventing that on the on every company. Last part, I mean second last part if you will, is that how do you interface with this fleet management orchestrating part. And before I get that, so one of the criticality here that last time around your onboard autonomy and the fleet management and the orchestrating part was such a tied down, is really the reasoning is the technology reason. Because last time around onboard autonomy was not powerful enough, the processing was not powerful enough on board. So a lot of the high level complex algorithm was actually shift to this orchestrating agent, if you will. And that is why I am shifting certain algorithm back to the cloud. That's why when I was developing autonomy 1.0, I had to have the tether to that. I cannot just switch to any autonomy, any FMS. This time around that got changed. This time around what happened, we have a very clean, clear set of responsibility. What is onboard supposed to do, what is this cloud supposed to do. And I used FMS as a simplifying, but this is really your fleet management, your route optimization, your orchestrating agent, all kind of combined together. But this time around, this, I know there is a ISO standard going on. This is very clean. We actually very nicely know what is onboard supposed to do, what is my cloud supposed to do. Obviously, cloud has a different piece. We know each of the pieces what's supposed to do, and what is the basic set of information that has to go back and forth. So this is not that this time around it got a lot more easier because we didn't have that absolute tether between the two. Because last time around, this guy was asking this FMS or the cloud solution to do certain portion of the work that was not getting done here. That was the umbilical cord, if you will. That's why we were not able to detach that. This time around, it is a lot more cleaner. We know exactly what to go back and forth. Obviously, it can be added a lot more, and that's why there is a standard coming along. But it's a lot more cleaner this time around. Same actually goes in the downside also. I showed the upside. So downside means now the truck needs to also communicate and get certain information from the truck itself, right? And that also fairly well understood. Obviously, I didn't put all of it. I used certain, high level bucket, if you will, but it's getting a lot more nicely coming, off the shelf. So now if you think about it, somebody is good at making the drive-by-wire, somebody is making good at sensor, somebody is good at making autonomy software, somebody is good at making cloud solution. You want to take the best of the both solution, and it's almost impossible. Think about, if somebody is good at making lidar, they're probably not good at FMS. It's just not going to happen. Lidar takes a different type of technology. AI compute platform take a different type of technology. Autonomy takes a different type of technology. Knowing the truck takes a different type of technology. You just don't have one entity knowing everything through and through. A last thing I will kind of point out, the safety. There is a lot of talk about safety. Obviously, safety is a critical point, but I will not use the same. I mean, obviously the one that we know, I'm not going to touch upon. If you think about a autonomous vehicle is running your whole vehicle, a algorithm is running your vehicle, how to manage it when AI comes into it, it's an unsolved problem. So it's not like something anybody have figured out. Now, there is a different safety standards and practice people use, and I pull one that is being used I think this is a standard architecture, but this is also being used in Googles and Apples of the world for their autonomy. And this is high levels. There is nothing hidden there. Anybody kind of figured out any of the pieces. Let's say, some people have done the hazard analysis, come up with a thousands of way a autonomy can fail. We don't think that's something completely shareable. If somebody is doing certain way, figure out a solution that is very much shareable, and if we share the safety understanding and the strategy and the output and the what we everybody is doing, only the whole community will benefit. So that also goes into the interoperability. If your API hold into it, your modularity, your API, you can very freely share your safety, and it will actually speak the same language, and all that will help you to accelerate the progress. I think that's all I have. I want to give it a lot of time, and I know it's a lot of technical. So if anybody has any question, I would love to kind of take up on this question, but let me pause there.
Thank you so much for the presentation. We actually have two questions here. So one is from Osvaldo, that he is asking that if you could you use the Tesla software? I don't know if the question explains itself well, or I don't know if Osvaldo, can you ask the question?
Could you use the Tesla software? So you can't use the Tesla software. Obviously, that's proprietary. What you can use is the knowledge and the framework that is got out from this company, not just Tesla, Apple, Google, Aurora, Argo, whoever you think about is the best of the best, because this industry is going to a point, it's still maturing, but it's almost getting to the point, another 3 to 5 years it will get matured. So this is not going to be something, we are still figuring it out. So answer to that question, yes, you can use Tesla's ideas and thoughts and the framework, obviously not software, but yes, that's why you can accelerate, because a lot of those knowledge is out.
Perfect. And looks like we have another question from Gabriel. How Safe AI are seeing the process of interoperability that has been developed? You would put a great hopes on that?
That's a loaded question. I think there are two things, right? When you take this kind of standard has to be consensus, right? Everybody has to come together, agree, fight, kind of discuss and look at from different angle. So whenever you look for a consensus, it's gonna be by virtue gonna be slow. It just comes with it, right? You make a standard, it has to be slow. And for our safe AI point of view, given that we are a startup, obviously it doesn't work for us because it's very slow. That being said, we know that's the nature of the beast. If you want to do a standard, it will so what we are doing, we are actually actively participating and open to contributing anything we do. For example, DriveByWire API, we have a version done, we are very open to contribute. But we run in a much more faster space than any of the standard can run, just because it requires time to get everybody's opinion in the same page.
Okay, looks like we have another question. How is the protection of intellectual property with an open architecture?
So I have a philosophical view, and then I'll give you the down to earth answer. So the way technology is moving today, the pace is so fast, you almost don't want to worry about IP, because the IP you think is important today, 2 years from now, your IP is almost useless, because it's moving really fast, right? If anybody think they got figured out something great algorithm today, guaranteed to 2 years down the line is going to be no use. That's the speed of autonomy going on. To your other point, because the APIs are very well understood, now the each of the block you are doing, you decide where you draw the block. You want to do the whole autonomy, you want to give somebody the drive by wire. So once you draw the block, this is what I consider to be black box. You can keep your, keep that as a black box depending on your business case. But really it should be guided by your business choice. Like where is the value come from you? You as a mining company doing a better object detection, does it give you more value, or you as a mining company doing how do I use that autonomous truck better is a value. So it should be business guide why you want to protect something, not technology driven.